And there we are. So welcome everyone. I want to wish everybody a happy Thanksgiving for those of us that are here from the U.S. and certainly a happy holiday with the holiday season just right around the corner upon us. Thank you as always for taking time out to come and join me on these interesting Cinemeric based topics. I hope you guys enjoy watching and experience it as much as we enjoy certainly presenting. So today we're going to kind of delve into the world of structured programming. So hopefully we teased you a little bit with the little subheading, bringing order to chaos. But I think you're going to see, if you're not familiar with the term structured programming, it's kind of an interesting technique of laying out your programs to make your machines a little more proficient. And those of you that know it, but maybe know it from a certain angle, are going to see how it can be applied to all kinds of different applications. I will be your host, and I specifically say host today because I will be joined by a guest presenter. He's coming up here in a second. Some of you that were on a little earlier may have heard his voice. But my name is Chris Pollock, for those of you who don't know me. I manage our Virtual Technical Application Center, and for sure I am a resource here for you guys, as well as my colleague who you'll meet in a second, with any questions to do with Cinemeric operation and programming centric. So we are here as a resource. Please feel free to reach out if you need some help. We certainly like to give you guys an area, if you're not familiar with it, where you want to go and look for some information. So our core website is our CNC for You website. So by all means, check it out if you haven't been there. All of these webinars are promoted there. Upcoming webinars are there, as well as our training classes are promoted there. Here we do have a virtual section where you can download a content manager. It's pretty handy to have if you haven't already downloaded it, where we have links to all of the online material we've created in the past. So you can certainly get this content manager. And I would say if you've downloaded it already, go back and get a fresh one. We usually post a new one probably every quarter to 6 months. So it's always good to kind of pull down the latest one. We also offer a lot of training solutions certainly outside of these webinars. So from the training perspective, now we've certainly hosted a lot of in-person classes in the past, and you can see the classes that we're hosting. Obviously right now it's a challenging time that we're all dealing with the current travel restrictions and COVID challenges. So we are actually transitioning a lot of our original in-person content to online instructor-led classes. So what I would say moving forward is keep an eye out on this website, because under the virtual training tab, we're actually going to have regularly scheduled online classes. We've done a few. You guys may have seen them promoted in the past, over the past few months, where we just kind of email blast and did it kind of ad hoc. Now we're going to commit to a regular schedule. They'll be posted. You'll be able to register. Class size is limited because we want to encourage that kind of one-to-one interaction between our instructors and our attendees. So if you miss this one, hopefully you'll be able to register for the next one. But keep an eye on that virtual training tab, because that's where you're going to find the online instructor-led classes that are really supplementing the lack of being able to do in-person training sufficiently. Also, another good resource for you is our Mr. CNC YouTube channel. So if you haven't been there, check it out. Just go to YouTube, type in Mr. CNC, you'll find the channel. There's a lot of material, like the webinars that we put out on YouTube as well, but I also do a YouTube live series, which is a lot of fun. I get a chance to get in front of a machine and cut some chips and occasionally crash it. Lightly, of course. But if you haven't checked out one of the YouTube lives, I try to do them every month, and I am scrambling to, but I'm hoping to put one together just before the holidays to do a Christmas special edition. So I'll just tease you with that. Keep that in mind, and you might want to keep an eye out. If you follow the channel and you hit the little bell, a little reminder icon, when I do put up new material or we're promoting a new event, you will get a reminder on that. But without further ado, I want to jump over to my guest presenter today, Danny Vitullo. Daniel is a territory manager for Siemens, for Cinemeric. He's a product specialist like myself, covering the Rust Belt. Danny comes to us. He's been with us now. You just had an anniversary, Danny. What's it been, 8 years now?
7 years.
7 years.
7
Okay, you
years. Yeah.
updated it. Yeah, I see it on the slide, but I didn't think you had updated. So 7 years, a long time. So Dan, welcome, welcome. Everybody say do the virtual hello as I say hello to Danny, and Dan is going to step us through this world of structured programming. But I do want to plug one other resource that we have, and it's actually a resource that Danny manages for us. That is what we call our VPE, our Virtual Product Expert sessions. So what we offer is we offer usually 1 hour segments where you can engage with any one of us, Danny or myself or one of the other guys, and we can do some one-on-one online training, go through different topics, content. So it's a great way to get a chance to engage with one of our product specialists if you need to dig into some topics from an operation programming. And we base them around your interest, your questions. So if you think this is something you'd like to schedule, one of these virtual product expert sessions, just reach out to Danny there with his email address, and he will certainly plug you in and give you a time slot. But without further ado, let us switch over. Dan is going to take over presenting here. So let me stop sharing and we'll switch it on over. All right, Dan, you should have it here anytime now.
You got me?
We gotcha. So I'm gonna quiet up here, and we're gonna let Dan take the reins, and I'll be back in and out, but I'll also be on the Q&A and chat panels to try to help you guys out a little bit. As you know, questions come up, pop them into the Q&A section. We'll probably reserve most of them for the end, but if I see a little spot I can jump in, I'll try to. But with that being said, Dan, the floor is yours.
Thanks. And I would say, Chris, you didn't crash the machine. You had a small interference.
See, I need collision avoidance.
Yeah, there you go. There you go. So speaking of collision avoidance, here's a machine with collision avoidance. But so today what we're going to be demonstrating is the use of structured programming. I'll be covering functions that we haven't really covered yet in any of our virtual series, as well as kind of building on some that we already have from previous events. So through the use of this logic, we'll be able to maintain not only the subroutines that we have programmed, but also inspect tools for breakage, and we'll start to open up the door to see where else you can apply this and how you can find these issues that have been occurred during your program by checking for them and then resolve those issues and then continue on. So that being said, first thing, we're going to do a little quick just review of the documentation. I'm going to give an explanation of what structured programming is, how you can benefit from it. We'll quick review of some variables, and then, as I always like to do, give some suggestions of things to look out for. Logic statements and fundamentals, and then the actual programming examples where we will be implementing structured programming. And of course, we will have questions for coming up at the end as well. If you have any questions during the presentation, you're welcome to ask them in the chat. And as Chris said, if they seem pertinent, he will interrupt at that point in time. The controls that are covered under this webinar are the 840, 828, as well as the 808. So all three of our controls are all fall into this category of being able to implement structured programming. So first thing, the documentation that you're looking for primarily is going to be found in the job planning and the system variables manual. And you can get to those by going to the industry support manual or webpage that we've shown this multiple times. You just go up to the search and you type in what you're searching for, and then it'll take you to that manual. You can actually select a version if you have an older control and then get to that manual. You can either download it or view it online, but all the information that we're covering is all in these two manuals. This system variable manual comes in really handy when you start trying to monitor things like tools or any of this thing that's back in the system, not like a R variable or a GUD or something like that. It's something that actually is the system specific. Highly suggest getting to the Mr. CNC channel. If you're unfamiliar with variable programming and you haven't done much of it, these two webinars that Chris has done in the past are foundational to what we will be covering today. If you review these and then review this material, it'll all kind of flow together and start to make sense. But definitely the foundation for what we're going to be looking at can be found in these two webinars. So firstly, what is structured programming? Structured programming divides the programs into a hierarchy of modules. That hierarchy is controlled by logic, and logic is really what makes that, is the logic of the structured program creates this situation where you have the structured program is facilitating or enforcing conditional logic. It's aimed at providing the clarity and quality and development time, or sorry, improving clarity, quality, and development time of a program by making use of structured control flow and repetition. Block structures and subroutines in contrast to using simple tests and jumps, such as a go-to statement, which can lead to the code being potentially difficult to follow and or maintain. So by using the structured programming method, we eliminate a lot of those jumps and go-tos and skips and things that we normally would do, where our program becomes this long string of things and it's hard to keep track of where anything is. Logic is what makes it special. So the structured programming logic allows the CNC to maintain operational conditions that otherwise would require the operator to track and maintain. So like that old way of just putting a bunch of jumps and go-tos and backs and things like that in your program, the structured program will maintain that for you through the use of variables. And some of these everyday tasks that we want to do, even advanced tasks that we want to do, you can greatly simplify those by using structured programming. So things like pallet systems, subroutines, robot handling, tool breakage detection, things like that are just a few things that we can do and use structured programming to be able to maintain this hierarchy of the program. So how do you, as a programmer or operator or machine shop owner, benefit from structured programming? Process tracking, process control, and in-process testing are just three big things that come to mind when I think of structured programming. It facilitates the creation of these programs that benefit from reusable components. Most modern programming languages that we see today use some form of structured programming. The syntax may vary, but the components that are created to be reused throughout the program are very similar to traditional subroutine structure, but with the added benefit of conditional logic. And that's really the main piece there that needs to be understood. It's conditional logic. It's not just logic, but it's logic based on some condition. So when we're using structured programming, we let the CNC have intelligence that aids in your success. So think of it as having your control watching your back. If a process is aborted before completion, the control can know where that program was last at and start from appropriately, avoiding issues while simultaneously reducing cycle time. In our example, we will not only be using logic to control the subroutine calls, we will also be monitoring our tools for breakage. If you are running a job with multiple tools and each operation requires the previous tool to have been completed, or you run the risk of ruining or scrapping your material or your part, what do you rely on to monitor your process? What are you currently relying on? Are you just hoping that the operator catches that tool broke before it continued on? structured programming can monitor that's things like that for you. So, quick little review. We have two basic types of variables that we're going to be using. We have predefined variables and we have user-defined variables. The predefined variables are things like your R variables, your GUDs, your tool set, your tool length. Those are I'm sorry, not your tool length there, but your GUDs and your R variables. The user-defined variables would be like your tool length, any string variables that you're putting in or definition statements that you're putting in your program. Those would be user-defined variables. And again, we've covered these in previous webinars. If you don't understand the difference between these two variables or don't know how to use them, again, you can review those webinars or set up a VPE session with one of us. Now for the suggestions. Some very good things to keep in mind when you start using structured programming. It's a good idea to only put one statement on a line. It keeps things from getting confusing if you just string statements out. Use meaningful variable names and function names. If you don't do this, it again becomes difficult to follow what you're doing and what you're creating. Divide the program into subroutines. So instead of having that structure skip around in your program, have it call subroutines. Each subroutine should perform only one task. If you start creating multiple tasks in a subroutine, you start to lose the benefit of the structured programming. I always like to include messages in my subroutine. So while the subroutine's running, it gives me a message at the top of the screen telling me which subroutine I'm in. Always use the end if. You can get away, and you'll see what an end if is in a moment here. We'll explain it, but the end if is like the modal cancellation of your logic question. The control will run a lot of the time without the end if, but you run the risk of further issues if you don't end that modal. So it's best practice, always use your end if. Keep tool management in the main program. So don't do your tool calls in your subroutines. If you keep your tool calls in the main program, again, it keeps it much easier to maintain what's going on in your main call. And keep anything technology specific in the main program. I always use, and a quick little tip when you're building your structure, before I start doing my subroutine calls or any of that, I always just use the message command for testing. So I will test my logic prior to even running my subroutine. That way I can just make sure that the logic I'm writing makes sense before I'm waiting for maybe a 1 hour subroutine to run through only to tell me that it's broken. So I can do all my logic testing prior to any machining operations.
Hey, Dan, we got a question came in on that slide.
Mm-hmm.
Can you give an example of what you mean by a technology call?
So anything that is like a head change or maybe a kinematic change to the machine or maybe a palette change, things of that nature.
How about
Any other?
like a high-speed call, like a cycle 832 or something along
Yeah,
those lines?
cycle 832, cycle, yeah, exactly.
So probably
Top
something
surface.
something that an operator has a tendency to need to maybe manipulate.
Yeah, exactly. And that's the
Gotcha.
point of keeping it in the main. Sorry, Chris, I should have explained it better that
No,
way.
no, that's
You're right.
perfect.
Yeah, yeah. It basically what you're doing by trying to keep like your tool calls or your technology calls in the main program, it's for accessibility. Um, those are the types of things that you're going to possibly have to manipulate on a regular basis. So keeping them in the main makes it that much easier for the operator to find them and not make mistakes, right? Because if you're bouncing around from subroutine to subroutine, then it's easy to lose sight of where you are. And that's the whole point of structured programming, is to simplify everything so that you don't lose sight of where you are. So you kind of mitigate that if you separate those types of operations outside of the main program.
Perfect. Makes perfect sense.
Yeah. So logic statement fundamentals. So for those of you who aren't familiar with conditional logic programming, the basic thing is you have a conditional question, in this case, if. So once I implement an if, that tells the control, hey, what are you waiting for, right? And then if that condition is met, so whatever the condition I have in my if statement, it will then, if I satisfy that, it will go to the go to and then jump to or execute whatever code is there. In this case, we'll just say go to. If it doesn't satisfy the if, then it will continue on down to an else or go into some form of a stop or something. And then the end if cancels that modal if, and then stop read stops the look ahead. And this is just a basic structure of what you would see in a basic logic statement. This is not yet structured. This is simple logic. So let's start looking at how we program some basic logic statements in the control. So think of them as branches. So conditional statement is a branch if, else, and if. With conditional statement, with a conditional statement, the program block between if and end if is the only executed when the condition is satisfied. The branch if, let me go to my, and actually, you know what? Instead of talking about it, let me show it. Let's go to our control. And I've made some little examples for us to save some time. So if I am wanting, or if I look at this program, I have a pretty simple logic statement here. If R10 is equal, which means it is, exclusively is, 1, go to start. So then it would then jump to the label start right here. If it fails that test, and think of this if as a test, else go to end. So then it'll go to end if it fails. So when I run this, and I have just a quick little to make it easy to edit, I have a R10 equals 1 up here. When I run this, it's satisfied. R10 is equal to 1. If I then come in here and I change this to anything other than 1, because it's an exclusive, 1 is the only thing that will satisfy that if question, then it will say R10 not equal to 1. It locks down on this last message here, R10 not equal to 1. These message commands are the easiest way to build structured or any kind of logic-based program prior to putting in your real code you want to run. If you're just wanting to test the validity of your logic, coming in here with these if commands or with these message commands, and for those of you who aren't familiar with it, you just type the word or type MSG bracket quote and then whatever you want to say, end quote, end bracket, and then, or parentheses, I'm sorry, not bracket. And then the control will return at the top of the screen that message that you saw, in this case, not equal to. If I want to satisfy that, all I have to do is then go back into my program and make it 1. Once I execute it, I then get my message of equal to 1. So you can start to see the way that this if else condition starts to work. And again, always want to make sure you put your end if in there as well. If you don't have the end if, things can get wacky quick. It's a modal. Stop read. This is another important function that I see get used, sometimes not quite correctly, but what stop read is it affects the look ahead. So the Cinema control has a very advanced look ahead that aids in high-speed surfacing. Look ahead buffers large portions of code while the program is being executed. This can cause issues with functions like messages and conditional statements when you're trying to use logic because the look ahead gets past it. So the stop read statement, all it does is it just stops the look ahead on that line of code until it gets to the next line of code, and then it will continue on and go back to being active. It's not a modal thing. It's only at that point. So it's required in a lot of this type of programming that we're doing because we're counting things and we're trying to maintain these things in real time. So as an example of a stop read failure, let's take a look at that. What can happen? So in this example, with my stop read in the example, all it is just a simple message. And again, I like to use messages to test things. This loop command, so if I initiate a loop and then initiate an end loop, it will continue running whatever I have in here until I reset the control, or if there's a loop count or something like that. So if I execute this and then run it, you can see programs stop read program correctly. That's the message I have. With this message up, that tells me that the loop is continually working correctly. And you can see I'm still in execution of this program. It's still running, it's just in an endless loop. Now, if I break this and I come in here and I tell it, just comment out my stop read, then I'm going to get a totally different result, just that one little code. Basically, what's going to happen is I'm still going to be in a loop, but because of the look ahead, it never had a chance to display that message. It actually displayed it for a millisecond, saw the M17, and then stopped the and then canceled the message. So this is just a small example of where your stop reads can mess you up. They can also mess you up when you're starting to work with string variables and things, and I'll give another example of that later. Now, this is where we first start to really begin to talk about structured programming. There's a very important piece to this puzzle, and that's concatenation. And I know that I'm pretty certain we haven't talked about this yet in a webinar, but what concatenation is it's a function that allows a programmer to create a string that is configured from individual components. So that's a whole lot of words that basically means putting things together. So the concatenation is realized using the operand less than. So you put two less thans following each other. Then it has a string as a target. So you create a target after your concatenation. And then and that can be an integer, a real, a string. It can be just about any kind of value that we can program in the control, words, letters, numbers. And then what it'll do is think of it in formal language, like so, as opposed to like computer theory. The concatenation is the joining of those characters together end to end. Example, snowball is a concatenation of snow and ball. So it puts those together as to one statement or string of variables. So looking at what concatenation does for the control, we'll go to our first example, and I have two examples here of concatenation. It's as simple as, and again, I like my message statements here. So we're doing a concatenation here to return the value that is in R30. Here it's R31, here it's R32, and then here it's all three. So when I run this program, my first one is my first message is just, hey, you're doing concatenation. Then concatenate 4, then 5. So then all of them together. So the first run of it is just R30. R30 is 2. R31 is 4. R35 is 6. Then all together, or I'm sorry, 30, 31, and 32. And then all three together are 246. So you can see how it just stacks those together. The way I get this space after is by putting a space inside my quotes here. So if you look at the quotes, you can see there's a space in here, and that's how I got the space before the concatenation. The concatenation always stacks it right on top of the previous element. So they're always joined together. Then the second example. In this, now we get into using that concatenation to do some structured programming. So the first thing I've done at the beginning of this is we have a string created. So it's the string name is underscore sub underscore call. Another good little tip, anytime you're creating labels or strings or anything or any kind of variables or anything like that, always it's a good practice to put an underscore. I wouldn't say always, but it's a good idea to use the underscore at the beginning. None of our internal routines or variables or anything are going to start with an underscore. So by putting that underscore, you're eliminating, if you wanted to use the word, a word that we already are using in the control for something, then putting that underscore, or maybe you accidentally did it, putting that underscore will kind of keep from that crashing against each other. Then I'm using my conditional statement to say that if R1 is less or greater than 0, go to start. So any number larger than 0, it's going to go to the start. Else, R1 equals 1. So it's going to automatically, if R1 is 0, it's going to automatically put a 1 in front of it. Then I end my if. Now here's where things start to get tricky. This concatenation of R1 to opt, what that's going to do is every time every subroutine that it runs, it's going to call the subroutine, the subcall, based off of opt underscore, and then it's going to add a 1, 2, 3, whatever R variable by using this R1 plus 1. And I'll break this down a little further when we get into the main example. This is just a quick little teaser. So when I run this little program, because of that concatenation of the R variable, now I'm in sub 1, sub 2, sub 3, and so that call is being controlled here by this variable that I created, this string variable. So the string variable sub call is equal to opt and then the concatenation. And this is where it gets a little confusing to follow, but the magic that happens, if I reset this program and restart it, it starts back at the beginning of the program that it was in when I stopped it. That's the real key there, regardless of what I do. Or I can even come in here and I can change this and have it start at a different program. Since this is 4, now when I go to run it, it's going to start at subcall 4. Because of the logic of the way that that concatenation of this subcall works. And this is the foundation of what we're showing you. It's a very simple little thing to add that gets really powerful really quick. So all that being said, I'd like to run now the final exercise to completion and show you what it's doing. So let's go ahead and run this guy, and then we'll break it down a little further, and then we'll show you some failures. So this is the program that we will be running, or that we are running. And I'm going to go ahead and go into the machine space view so you can see it a little better. And I'll lower my detail level so you can see inside the machine. So if I run this program, it will run to completion, and every operation is a subroutine, including the probing cycles, that's being controlled from a main. As it's running, you can see it's checking the subcalls up here, or giving me my message as to which subcall it's on. After each operation, it goes over and probes the tool. And what the probing is doing is it's running a little tool breakage detection that Chris has shown us how to do in a previous webinar. So what is actually physically going on here? So as we look at this program and, excuse me, take a drink of water here. As we watch this program running, as it's going through, first thing that happens is we get our conditional question if. If R1 is greater than 0, go to start. So that would then induce it to jump down to the start location in the program. Else, so if it doesn't meet that condition, else R1 equals 1. That R1 equals 1 would then cause it to then implement the R1, and then this definition statement, or the definition of the string that we've created, then becomes op_1 because of this R1 equals 1. And then it says, then the next command is go to subcall. That go to subcall would then go to whichever subcall is equal to the string variable that's been created. So now let's take a look at that a little bit closer in the control itself. So if we break down this program and we look, we have our string variable that we've created. Then we come into this I'll explain later. The if statement. So we have our if question. If it's greater than 0, go to start. Well, if it's not, R1 equals 1. And I keep on saying this, but the only way I know how to show it is to just review. So this concatenation of the subcall op_1 is going to then concatenate into whatever value gets pushed to the string. And after each subroutine, I add 1 to R1. So when it gets this subcall, every time you go to rerun it, it will then look at the R variable and then jump to that subcall. And that's the way that it knows where it's at, including a complex program like this. So when I run this program and it's running, I can see I'm in sub 1 up here at the top. When it's done with sub 1, it goes to sub 2. If I stop it in the middle of sub 2 and hit cycle start, it will start again at sub 2. I did no block search there. If I reboot the machine and come back to it, if the power went out and I come back to it, it will start at the beginning of the last subroutine it was running. And that's all because of the way that this structure of this program is written. And you notice the the subcalls are all broken down into these sections of operations. So here's my label that I create with that definition statement. So everything in between this label is my subcall section. Separate my tool out. I have my message command. Um, then I also have in here my tool break detect. And this is the one of the big pieces of this puzzle that we've used structured programming to highly evolve this program into something that does a lot more than just call subroutines. Imagine this program running overnight or over the weekend or lights out or whatever, and you come back and 10 minutes after you left the building, your tool broke and you didn't know it. This will be able to monitor that. And granted, the program that cycle that's running, or that subroutine, is going to continue on to the end. But when it's done, it's going to test the tool using this simple little tool breakage detection cycle that we've created that monitors the tool length. And I have a threshold in here, and that's this first. When I said I'd come back to it, the threshold for the tool length is R20. So I'm inspecting the tool, and if it's anything less than the tool when it was tested or when it was originally installed, then it's going to give you an error, and this is the threshold of that. So what happens when it breaks? So that's this program. In this program, down at towards the end of it, prior to the op4, I have inside of op4, I have a threshold, and I'm breaking the threshold. Basically, I'm telling it that the tool is shorter than when it started. So when I execute this and I run it, when it gets to subcall 4, or when it gets through with subcall 4, I should say, it'll fail. And it'll go into this endless loop that I've created. Now, if I had this stop read wrong, this loop would break, and it would actually allow me to continue on with the program. If I go to run it again, it's going to run subroutine 4 again. Now, I could put another block in there where it won't allow me to run it again, but I didn't for this exercise because I wanted to show the basics of it. So with that, I wanted to open it up to some questions and see if anybody had any questions that they had, or.
Perfect. Great job, Dan. And yes, we've had a lot of good feedback from the audience. And I want to say, let's keep coming them in. This is obviously intended to be one of those topics where we'll probably have a heavier Q&A period than normal, because it is such a kind of an intense topic. So I do have to bounce around here a little bit between the chat and the Q&A, no problem. So bear with me. This was an early question regarding going over stop read. I know we've had a few of questions regarding stop read. So let's I'll wait till one of the later ones, because I think there was a better description of stop read. We did have a question come in. Will the control support while functionality for looping subs? I think you did go through it a little bit.
I'm looking to see if I did. I don't think I covered while, but yes, you can use while.
Yeah, so you can use it like in a counter situation for
Mm-hmm.
sure if you want to index down. And it's going to work similar to like you would normally expect it to work in a standard programming format. Um,
What was the
if my
stop read question?
machine, we'll get to it. there was a couple referencing it, but there was a little more detail one I saw come down, so we'll get to it. Here's a good one. If the machine for some reason needs to be powered off for a reboot, will it be able to keep the R variables to start the program from where it was stopped even after that?
Yeah, not a problem at all.
So R variables are what we would call a non-volatile variable. So with that being said, whatever value is in there is going to be maintained. The one thing I'm sure Dan would agree with me, you do want to be a little careful with R variables because although they are there for you to use, they're certainly there for others to have used. So you do want to watch out sometimes when it comes to R variables.
Yeah.
Okay. Um,
That's just on that note too. That's why like this subcall string, that's why I tend to use a lot of local variables, which is what this would be in situations like that. For the value that we're using for the subcall, it's just the easiest thing to use is the R variable. But you could technically create a integer to use for this and maintain it internally. But man, as soon as you reboot the program, no, you couldn't do that actually. You'd have to use a GUD or something like that. You couldn't use a local variable for this. It wouldn't be able to count it.
Yeah, and actually that leads to another question that I just saw pop up over here. How would I do structured programming without R variables? And Dan just answered that quite eloquently. You would need to use GUD variables.
Yeah.
So really an R variable is a GUD variable. It's just they're predetermined for you.
Mhm.
So GUD variables are global or channel specific variables. Why don't you jump to them there, Dan? Where you can create your own and they can have any term and they'd be owned by you because you build them.
Yeah.
If you're interested in making GUDs, as Dan mentioned, go back to I don't remember if I did it in the basic or the advanced variable programming webinar, but I certainly went through in detail and we actually built a bunch of GUDs.
Yeah.
But that would be the best way for sure.
And if you go to the comment sections of the webinars, most of them have a like a timestamp with a description, so you should be able to find it pretty easily.
Absolutely. Does the Siemens NX CAM platform support structured programming integrated into post-processing with the post configurator? So we happen to have Michael Menino, a good friend of mine, and he works for NXCAM on. So maybe he can jump in and answer that question for Grant. But from my perspective, I believe that is true. That the NX, I don't know if it supports it through the post configurator or how you would actually set up the post processor, but I'm highly, convinced that NX would support outputting structured programming. But Mike, if you hear this and you can reply to that, we'll see if he pops back in. But I believe that is the case. Okay, would it make sense to have a run a sub at end or beginning to reset all variables? Yeah, so in a lot of cases you'll see that, right, Dan? You'll see at the very end of the part program, you can force all variables to go to a reset state. Kind of depends how you're using them. In the structured concept that Dan's showing, he's setting and then resetting by the behavior of the structure. So in that case, you don't have to reset them, nor would you really want to, because that's going to keep track of which sub you were in based on the state of those variables.
Yeah, and that's maybe a something that in hindsight I probably should have mentioned, but if you at the end of your program, if you don't reset your tracking variable, whatever you're using, whether it's an R variable, in this case R1 or a GUD, if you don't reset it to the base state to start the program from the beginning, it will fail. So if I was to take this same program and just comment out this reset of the variable and go to run this, and I'll start it at later on in the program. That way we're not sitting here waiting for it. I'll start it at 5. And then when I run this now, it's going to start at subroutine 5, but when it gets to the end and runs 6, the final subroutine, once it's done. 6 is pretty quick. It's just a finish pass. Now, if I was to rerun it again, it's going to keep on running 6
Right, because you never reset it.
because I never reset it.
Yeah, good example.
So so you want to make sure that, I'm glad whoever brought that up.
That was Mike.
Good
Yeah,
question,
good
good
question,
question,
Mike.
Mike, and I'm glad you brought it up because the teacher neglected to teach.
So Shane
So
asks, what part of this would I use in conjunction with CAM programming machine?
So what you would there's a couple of different things you could do. So one thing, if your system that you have supports outputting the structured program or has some form of a post processor that will output the program into a structured text, you could you could output the whole thing that way. I've seen some things, and it's usually some kind of add-on to the system, but what I generally will see is people outputting the routines as as separate calls, you know, outputting it as a subroutine call program where you have mains and subs, and then adding in the structure for the subroutine calls. So instead of having the sub call be the the name of the sub call, in traditional in Siemens world, sub calls are pretty easy. You got two ways of doing it. I can either go to the cycle and select a sub I want to run, and it automatically will go to that. Or I can actually just type the name, like this program is EX underscore one. If I just type, sorry, EX underscore one, it automatically recognizes that as a subroutine, and I don't need to go through the call. So if your CAM system is outputting or posting the program with the sub call names already, then you could manipulate those names, and then but you would need to have a similar, um you would need, how's the best way to put it, you would need to add in these this label for the jump, because unless you already have a post that's going to be doing this structure, you're going to have to basically go through and do what we did here. So if you had a program, say, let's go to my concatenate 2 one. So this is my basic structure for just about um, any structured program. That, for this is like a entry into structure. There's more that we can do here, but I wanted to give the taste of it, and then if this receives good feedback, then we could potentially do a little bit more on the subject. But this is here is where I would put in my call to sub.
So Shane did mention that they are using NX, and Mike was able to get back to me. He gave me just a little shot of what I believe is the post creator tool, and it looks like they are for sure supporting subprograms. I don't know 100% that it's also going to give us the logic statement for structured. But to kind of piggyback on what Dan's saying, I do this quite a bit, and what I found is the easiest, when I'm working with CAM, output toolpath, I like to build myself one main structured program header, right? So I have one main program that's kind of like my template file, and I may build it for, I don't know, 20 operations or whatever, probably like worst case scenario. And then what you can do, whether your CAM system does or does not support outputting, in a subprogram structure, you can just output all of your subs as individual files, dump them in a common directory, and then just update the sub calls in this template file. So just grab your template, rename it. Now it's going to be for XYZ part, and just make the link. So the main is really going to be typically programmed at the control, and all you got to do is tie the two together, and then away you
Yeah.
kind of go.
put your tool information in and put your sub call, and away you go.
Yeah,
And
I
that's
mean,
yeah.
a lot of times with that, I'll cheat and leave my tools in the subs because they're usually already there posted. But if you really want, like if it's a job that I'm doing that's going to be continuously run, it's a production, then I will go through all the steps of maybe bouncing in the technology cycles. And again, I did see another question on the definition of technology cycles. I think we covered it, but if not, usually I think of a technology cycle as um, any cycle that's going to kind of manipulate the toolpath that at a high level I would want an operator to change. So usually I would say think of like cycle 832 or high speed routine would be a good example of a technology cycle.
Top
Leave the
search.
subroutine to the meat of the toolpath. Okay, let's keep going because we got questions rolling in. So Andrew, suggestion, one thing I do is the jumps to something other than the beginning. I create an M0 with a message saying something like message you're starting op, push start to continue to reset or cancel.
That would be if you have the ability to have operator intervention. But yeah, so what Andrew's talking about, and I've seen Andrew's programs. I know who Andrew is. What they'll do a lot of the times is because of the nature of a lot of the operations that they commission for customers, there is customer intervention involved, or they want the customer to visually inspect to make sure that the fixture is correct or the tool is correct. So they will put at the beginning here in this message, like in this location, it would say, maybe inspect for blah, whatever, right? And then they would have their M0 directly following that, or an M1. So the first time they run it, they have their optional stop active, and then then once they prove out the whole process, then they'll release it. So it, it's it kind of that's basically what he's talking about, I believe, because I've seen their
Yeah,
program.
that
So
that sounds right for
yeah,
sure.
I've
Good.
seen
Okay,
Andrew's
well,
program.
let's
So
keep on chugging along. So Shane mentioned that he's going to have a WebEx with Tom. I don't want to butcher Tom's last name. Gents on Monday. He'll ask. Okay, cool. Um, Mike said that he's certainly becoming a fan of the 840 control by watching these webinars. What power? So certainly I appreciate that feedback. Let me bounce to. I got to jump over to the other section for some of the other questions here. There's always a lot of bouncing around with this stuff.
mhm.
Okay.
Lost you, Chris.
I'm just
Oh.
reading through. Give me a second here. Um, so what would you consider the most common application where you would see structured programming, Dan, applied to?
What I see a lot in my area is pallet changing machines. So guys using structured programming to, I have a customer up the street here that makes cranes, and they have a very large machine with 6 or 8 pallets. I can't remember now. And each pallet has its own program that's separate and its own fixture. And when they call those pallets, it tells the control which program to use. And if anything goes wrong with any one of those pallets, it will stop and call the next program and the next pallet and run that one and then flag the one that failed. So if they probe something and they probe the fixture before they probe the fixture, then they probe the part, and those have to jive. And if they don't, then it continues to the next pallet failure. The person loaded the wrong material in the pallet, and it won't even try to run it. So that's the kind of thing that I see more, but that's kind of the nature of my territory where I'm in. But I know also in turning applications, this is probably starting to take over when you have multi-channel turning, like turn mills. I'd say that's probably starting to take over. Would you agree, Chris?
Yeah, for sure. Actually, I mean, really, that's where structured programming in our industry started, right? I mean, you saw it truly applied to mixed technology, turn mills, especially multi-channel, where they had a lot of small operations. There was a lot of clearance problems, potential crashing scenarios. So that was really, I think, certainly where the industry first adopted the concept. But I use it, I mean, I've used it on simple vertical milling machines where we just wanted to kind of take the responsibility away a little bit off of the operator. So he kind of had just something watching his back, so to speak. If anything happens, he stops midstream. He doesn't have to kind of worry about it. I've done it a lot with my colleagues over at DMG, where we were doing like multi-vane impellers, anywhere where we have, you know, a lot of common operations and a lot of long tool path where we wouldn't want to start all the way from the beginning. It's a nice, easy way. So like on an impeller, right, you got all of those vane segments, and they're typically broken out as one primary tool path, and then maybe even just rotate it around. It might even be the same tool path. But how do you keep track on what vane you were in? Super
Mm.
simple way to add this logic in, manage your subs, and and handle that kind of toolpath. So this isn't reserved. And I know sometimes it seems like a very complicated topic, but it really is not reserved for complex machining only. I've done it on a three-axis mill that we were just, you know, banging through 4 or 5 operations, but we wanted to have enough sophistication there where the operator stopped at midstream, it would catch it for sure. So don't be afraid of kind of adopting it, even in a simple process. It really is a very strong way to kind of add that extra um, confidence to the operator. Okay.
Seven lines of code, and you've got the ability to test your not only that you're in the correct program, but that your tool was is correct. You know.
So can I use the concatenate command to combine a real and an integer together?
Hmm.
So
Yeah.
I think maybe it was a little confusing. It is kind of a tough topic when you see and try to describe. I always have a challenging time educating people on concatenate, but I think the big takeaway here to make sure everybody got it, and Dan, I don't know if you mind if I put it in my perspective, but concatenate is specifically used for string variables. So don't kind of confuse this. It allows you to take a string variable and combine it with a real or an integer, but you're going to apply it to a string variable. So as long as you're saying, hey, I have a string variable, and within that string variable, I want to be able to push in an integer or a real variable to it, like when Dan was displaying a numerical value, right? I think you used integers for those. I don't remember. Um,
Yes.
for
Yeah.
sure, but it is specific to applying with string variables. Um, how can you do structured program without R variables? We talked about that, right? So you
Hmm.
want to use your GOD variables for sure. That would be a way to do it. Okay. We use a technique similar to this for large parts with long run time that are not likely to run start to finish without needing a reset at some point. Yeah, great scenario where you would apply this. This was from, all right, and go to run. All right, let me keep going here. You get down to the bottom. Boop, boop, boop. So much
Oh,
jumping around.
I got a
Um,
syntax there. What did I do?
Oh, sorry, I missed how you got to the Excel sheet that you showed the link in the training material. Dan, do you have that slide or only I have that slide?
I
Um,
can.
well,
I
I tell you what, Ron, shoot me an email, Chris, C-H-R-I-S dot Pollack, P-O-L-L-A-C-K at Siemens.com. I showed it earlier, or Dan will show you his. Actually, Dan, why don't you pop your email up on the screen.
Yeah.
Ron, just shoot us a quick email and we'll just send you the link. And as to how to get to the page, though, we don't want to just send you the document. We want to show you where you download it because those do get upgraded all the time.
Yeah. Yeah.
Um,
1 sec here.
yep, Ron had mentioned how we had worked on an application together and used this for blades. Absolutely. Um, Oh, here we go. Yes, it's a good example of stop read correctly. So yeah, so Ronnie was trying to get his head around stop read. Could it start on the wrong? Yeah, this is a good example where you need to use stop read correctly. It could start on the wrong program if you don't have a stop read in the right position.
Correct.
Absolutely. Yeah, that the stop read is, people people sprinkle stop read like it's pixie dust, right?
Like fairy dust.
Oh
Yeah.
my God, I can't tell you how many times like, oh, put three stop reads in a row. Does nothing. Does nothing.
The, the,
Or if they don't understand what's happening, they just say, oh, we'll put a stop read. Stop
the
read's a very powerful command if you know how to use it and where to use it, but it is not the end all be all. Usually you're trying to band-aid something with stop read, you got a problem in your logic somewhere else.
yeah.
But it's just that. It's just going to stop the look ahead. So, when we write these small little training examples, there's so few lines that the stop read could already be outside of the program at that point. That's why we actually have a tendency to probably use them more than you would normally need it had it been, a fully posted toolpath.
Yeah. And the thing to remember about stop read is and this is the way I remember it is if there's something that will change in real time, then you need to look at using stop read. So anything that's going to change in real time, i.e. in the buffer, then stop read is required.
Right. So Spike was saying, in the way you're showing the loop and loop function with a stop read, it doesn't make sense to me. Why have the loop in the example of stop read? So why don't you bring up your example, Dan?
That was here. So the reason I use loop is because it's just an easy, quick, small way of showing it without having a big, huge program that I'm trying to break it down. So so basically, what's happening here is this message statement without the stop read will be lost in the loop, so to speak,
Well, it's lost because it's looking ahead and seeing the M17.
and seeing the M17
Yeah,
exactly.
that's the problem right
So
there.
in fact, I think it'll even fail if I put it after the loop.
Let's try it.
Yeah, see, it's still, and it fails too. So it needs to that it's the stop read is, obviously this loop is sending it back, but then you say, well, why does it hang up on the M17 if the stop read isn't stopping it? If the placement of this is important to get it to work correctly, and that's where this simple little exercise goes a long way to showing where this statement needs to be. And this is, again, why I use message statements to test these things, because it really, really helps to find out something is working correctly, right?
Absolutely.
Because that could have
So,
easily been a subroutine that it skipped over.
sure. So Mike mentioned that they use RG variables on their multi-channel CTX machines. So Mike is
Hmm.
is certainly from DMG. He's talking about the
Hmm.
Gildemeister machines. Now RG variables are interesting because those are channel specific R variables instead of global R variables. So I don't think this machine we have any built. Jump over to the variables offset
One second, I
table.
want to just, oh, what am I programmed something wrong. I'll have to look at that in a second.
No
My
problem.
eyes are cursed. You wanted to see which
So
variables?
see where the R variable button is. If you have a multi-channel machine and it's
Hmm.
commissioned that way, you can also have an RG variable
You'll
section
have
above it. Absolutely.
a global variable.
No, they're local. R variables are global.
Our
So
variables look at
RG.
RG or globe. Yeah, yeah, yeah.
Or maybe I mixed that. No,
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 you
no. I
mixed
said
it
that
up.
backwards. I
You
said that
said it
backwards.
backwards.
Yeah, RG would be a global variable,
Global
so they
variable.
would exist in both channels.
Hmm.
You can also change the state of GUD variables. They can reside either globally or channel specific.
Hmm.
What is interesting though, and I just ran into this not that long ago with global or the GUD variables, right? Globally defined variables or GUD variables that you're going to create and you want maybe to be channel specific. When you define and build the variable, it's always going to make the variable in both channels. You don't have the ability, it'll be unique, but if you make a variable called, underscore XYZ, and you define it, and you define it as a channel specific variable, you'll see it in both channels. The
Mm.
numbers won't transfer between the channels. They will be independent, but they will both be there. Okay, so let's continue on here. I don't like this new WebEx. It keeps changing my screen. I keep having to pull up the Q&A. Oh, it's horrible. Dennis says, do you have a reference about how much extra time can the stop read require from the total cycle time? It is not significant. So actually, it potentially isn't going to change your cycle time at all. Now, certainly, if you were like put it in the middle of like a rounding function, like if you were in the middle of a machining toolpath, then since there's no look ahead, it's going to complete that. So it's almost like issuing a G60. But as far as logic is concerned, it's still got to pass through that line. So you shouldn't really see any cycle time change at all. Or if you do see, it's going to be very minimal.
Mm-hmm.
Um, Not quite sure what Tom was referring to. He said underscore 33 equals 2. I don't know what that is.
Oh, that's because that's what I had messed up.
No,
I
he's
had
fixing you.
He's fixing my program. I had already caught that.
That's great.
I had wrote this. I had originally done this, and so he saw it, and I didn't see it. I didn't have an equal sign in there.
Uh,
I had it like that. So
Tom had your back.
yeah, he's got my back.
Good. All right. It looks like the last question, but hold on, I'll check up top. Was from Spike. So Spike was saying that he starts to see the counter scenario. So that's great. And yeah, I think we got everybody. If I missed anybody, I would apologize. Again, Dan, why don't you put the last slide up? If anybody has any further questions, you can certainly reach out to myself. Obviously, my contact was there earlier. Certainly, Dan is a great wealth of knowledge, as you guys have seen. Dan, I want to thank you for presenting and doing such an awesome job. So thank you.
No worries.
And with that being said, I want to wish everybody a very happy holidays. I'm hoping you can maybe join me for my next YouTube Live, my Christmas special. But if I don't see you beforehand, just have a great new year, and we'll talk soon. Our next webinar will be sometime in January. I'd have to double check the time. So with that being said, I'm going to stop the recording, and I'm going to say adios. So take it easy. Thank you.
Thank you, everyone.
Bye-bye.